My name is Shreyas. I work as a data scientist in a reputed service-based company. I have more than 4 years of experience in data science field and other backend technologies. Okay. So quickly moving on to our agenda, what we will be looking today is model deployment using Flask and Docker. Okay. So I hope you guys have Flask and Docker installed. If not, don't worry. After this session, you can try this on your own. Okay. We will be quickly going through how to work on both Flask and Docker to deploy our whole model into production. Okay. So yeah, thank you, Gurtej. So Gurtej has already given the to-do list to install all these things, right? So let's start our workshop. So the agenda for today's workshop will be what is model deployment and why do we need model deployment? Okay. Then we will look into an overview of Flask, an overview of Docker, containers and images in Docker overview, and then hands-on. Okay. Now Flask in itself is a different framework. You can dive more into that later on. Today we will be going through the basic only, just for the sake of deploying a model. Docker in itself is a big technology, and there are a lot of things that you can learn apart from container images. There are security layers. You can go through that later on, but for now, we will be just looking into basic implementation of Flask and Docker to deploy a model. Okay. And in the end of the session, we would do a hands-on using Jupyter Notebook, a code editor, Postman, and then we will try to deploy a model, right? Okay. So now one of the basic questions, why do we need model deployment? Okay. So let's say you are creating a machine learning model to say for example, you are predicting a breast cancer classification, whether the cancer is malignant or benign, whether it's harmful or not. Okay. You did all the data analysis, you did the pre-processing, you build your model, you have good accuracy. And you did all these things in your Jupyter notebook. Now, tell me one thing. What the issue with that is you can't uh, actually use this model anywhere. Okay, it's on in your Jupyter notebook. It's in your machine. But what valuable will it bring to your business if your business users are not able to use it, or the actual customers are not able to access your model? Okay, so this is a big problem. If you don't have your model ready, I mean, if your model is not into a production environment, if it is not accessible to user or any business owner for integrating it with the application or any user to predict historical live or future data, then there is no use of such model. Okay, just building a model in a Jupyter notebook is not the last stage. So model deployment is one of the last stage. There are other last stages like um, I mean, you have other last stages like model unit testing, model monitoring, and so on. But today we will look into how to deploy a model into production environment so that users can access it easily. Even the business owner can use the URL to access it easily. They can integrate this model into their application if they have any application. If they have any mobile application, iOS, Android application, they can integrate it easily. Okay. So so the main purpose of while deploying the model, our main purpose would be to recreate the whole pipeline. Okay, so if there are multiple steps, so we are not interested in EDA while deploying the model, because EDA is just for our understanding of what the data set looks like. But the other parts like treating the missing values, one hot encoding, and so on, all these data pre-processing steps, we need to add it into our pipeline so that when the user sends data to your model, the model should be able to predict it. Okay, so all these pre-processing steps should work on that data. Data should be converted to data should be converted to the desired data that the model is trying to accept, and then it should try to predict. Okay, so we need to recreate the whole pipeline, like feature engineering, feature selection, and then model prediction. So let's go to our diagram and understand it much better. So these are the phases that we actually work through during our model research phase. Okay, so what we do is first we gather the data, We analyze the data. Okay, we do EDA, we create box plot, understand if there are outliers or so. Next, we do feature engineering on the data, like we remove missing values, we may scale the data, we may remove, we may work on the categorical variables and so on. Then among all the columns, you would select the columns that are actually necessary for model building. And then you will build multiple models. And then the model with best accuracy and score, you can use that model for model deployment. So these are the research phase steps that you usually do in your Jupyter notebook. Okay. Now, say for example, you have a model ready. Now you need to deploy this model into a production environment, right? Now, what is production environment? An environment wherein user can access the model. Okay, where user can access the model. They can make predictions on their own data using that model. Okay, so there we have these steps. We have live data, feature engineering, feature selection, model prediction, and then the output of model prediction will be actual prediction, whether in our case it would be whether the cancer is malignant or benign. Okay, so this is the whole pipeline. Now in this feature engineering, feature selection, and model building, these three things we are trying to replicate from the research phase. Okay, so feature engineering and feature selection would be the same, but model building, we won't build a model in production environment. We will be using the model that we had built in our Jupyter notebook. We will be using the same model to predict the new data. Okay, so this is the basic uh, flow of our application in a production environment. So I hope this is clear to everyone. If any questions till now of why do we need to deploy model, please let me know in the comments. I can help you with that. Uh, until then, let me give you the URL. Give me a moment. Yes, Vishal. So we would be using JobLib library itself to save the model. Okay, and then we will use the same model to deploy it using Flask. So what we will be doing is we will be creating a model. We will be saving the model. Okay, and the same model we will try to implement, wrap it through an API. And now this API we will then deploy it using Docker. Okay, so we will see that steps as well. Any other questions on why do we need model deployment? Any questions on the pipeline also? So we would be doing hands-on as well, but for now, let me try to check if this URL is working. I think this URL should work because yeah, try to save it as CSV file. Are you getting any error while trying to hit that URL? By not working, are you getting any issue? Are you seeing any error on the page? Okay, so in that case, let me try to give you a, I will try to upload a CSV as well. Let me find it if I have here. Okay. It should be a CSV file. You should see. So let me share the screen. If you are able to see such type of numbers uh, in your screen while you are trying to access the URL, then it is working. Yeah, if you save it as CSV file, it should work. Yes, yes. This is the actual. So don't worry. We will be trying to load it later on. So don't worry about that. Okay. So I hope there are no questions on model deployment. So let's move on to the next slide on what is Docker, right? Sorry, what is Flask? So Flask is a micro framework in Python. Okay, why we use Flask is to build APIs for web application. So you would have while you build Flask API, you would have some URLs like /predict /home and so on. Okay, so Flask is very simple. It is not recommended to use it in production environment, but I used it just for the simplicity that it brings with the application. But other than Flask, you have other options like Django, you have Tornado, you have Fast API. Okay, but today we will look into Flask because it is much simple and very easy to use. So any novice user in Python can understand how to use Flask. So there are a few extensions in Flask as well, like SQL Alchemy and so on, wherein you can build a web application using some data by integrating some database with it. Okay. Now what we would be doing is we would be creating REST API using Flask. And so let's understand what is API first. So API is API is application programming interface, which is basically a set of rules that allows the programs to talk to each other. So you would be knowing that we have a backend and front end, like all those things. Okay. Now there is an API that runs in the backend. So when front end tries to access the API, okay, when front end tries to access that API, it would get some data, and those data would be shown in the UI. Okay, so this is an API. Now how to build this API, those rules are no are followed those rules are set by REST API. So REST API stands for representational state transfer, a set of rules that programmer follows while building the API. Now each URL of an API will contain a data. So you would be sending a data, okay? So it is known as request, and then you would be getting a data back. So it would be called as response. So in our case, we would be sending the data to predict whether this particular data is malignant or benign. So whether these parameters show that the cancer is malignant or benign, and in the output we will get whether the cancer is actually malignant or benign. Okay. So yeah, Rekha, don't worry. So when we do the hands-on, I will be installing Flask. You can follow me there. So don't worry about that. The main part here is you just need Docker and Postman installed. The other libraries for Python we can do. You can do that along with me. Okay. Next, we have a the main topic for today's lecture, that is Docker. Now, what is Docker? So you would have heard this phrase that it works, but it works on my machine. Okay, this is a popular phrase that is that you listen most of the times this phrase when you work in a software environment. Okay, so application works in your machine, but it doesn't work in someone else's machine. So you say, but it works on my machine. Okay, now why this headache occurs is the application that you build, it does not just depend on the code that you write to build that application. There are frameworks, there are libraries, there are OS dependencies, there are other tools, there are configurations that over all these things in all build an application together. You can't just use your code to build an application. There are multiple things that come into picture. Okay, so whenever you pass just your code to a tester, or say when you try to deploy a code using you just try to deploy a code in some environment, it would give you an error. It would create some problems because the OS that you have in your machine and the OS that the tester or the environment where you are trying to deploy the code, the OS, there would be mismatch in the OS. Okay, first thing. Second, the framework version, there would be mismatch in framework version. Third, there can be mismatch in Python version. So you would be using Python 3.7 and they would be using Python 3.4 or maybe 2.7 and so on. Same with the libraries. You would be using sklearn, some other version of sklearn, and the sklearn library that they have installed is some older version or extremely latest version. Okay, maybe they are not using a stable version. Now, to solve this problem, hypervisor came into picture. Now, what is hypervisor? Just in a nutshell, you would have heard of VMware and VirtualBox, virtual machines, right? Now, every system has an hardware. So right now you are sitting, you are using your laptop. On the laptop, you have some hardware like RAM, CPU, motherboard, and all those things. And then we install an OS on top of that hardware. Okay. Now, when you use hypervisor, this VM, the virtual machine is installed on top of your OS. Okay. And then on top of the hypervisor virtual machine, we would install multiple guest OS, and in each guest OS we would be setting up an application. Okay. Now the problem, how this solves the problem is the OS that you are trying to install on the virtual machine. You can create an image of that OS and send that image to tester. The tester can build an instance of that image, like you try to create an instance of a class into an object. The tester can create an instance of that OS, and then they can run their application on their machine as well. Okay. Now, but the problem here is each guest OS that you install on your hypervisor, or you can say virtual machine, they use the same resource on your laptop. Okay. Now, there is one thing. While installing a guest OS in your machine, on the virtual machine, you need to predefine how much space you need to give for that OS. You need to predefine what will be the RAM. You need to predefine what will be the CPU. So while building a virtual machine, you will go through these steps. But say, for example, your application is not using all the resources. So your application would be using just 1 MB of RAM and only some processing power. But you have already built built the OS with uh, 1 GB of RAM and so on. Now this RAM can be utilized. There is a wastage of RAM and resources. Now to overcome this, there's a software called Docker that we are learning today. So this disadvantage is overcome by Docker. Now Docker don't have all these things, so they don't have guest OS and all. The concept is same. There is you have your own hardware. On your own hardware, you have an host OS, your OS, that is Windows, for example. And on host OS, you would be installing a Docker engine, like all of you guys would have done already. Now on Docker, you would be running multiple containers. Now what containers are? Containers are not OS, they are just processes. Okay. And if one process is taking some less resource, those resources can be utilized by some other processes. So the resource utilization is much better here. And the second thing is Docker is quite small, flexible, and fast to use. Okay. There are some applications wherein Docker doesn't fit well, where only virtual environment fits well, virtual machine fits well. But in most of the cases, people use Docker. So today we will be using Docker instead of virtual machine. Okay. Now, while building all this, you would come through Docker images, Docker containers. So we will look into it one by one. So let me explain this concept one by one. So first we will look into the architecture of virtual machine, the hypervisor. Okay. You have your machine here. Okay. There is a hardware in your machine, the RAM, CPU, the motherboard, and all those things. Then you have a host OS, the Windows environment, the Windows 7, Windows 10, Ubuntu, or so on. And on host environment, you install the virtual machine like VirtualBox, VMware, and so on. And on top of the virtual machine, you would be installing guest OS. So this OS would have one application, this OS would have some other application, and then this OS would have some other application. And we can install multiple OS. Like I can install Windows 7, other OS would be Ubuntu, one OS would be of maybe Red Hat, and so on. Okay. Now, other problem with OS is that some OS needs the licenses, like Windows need licenses. So this also creates a problem here. Okay. Now the resources that you see here, the host OS and hardware, they are being utilized by all these guest OSs that you installed on your virtual machine. Okay. Now while creating a guest OS, you need to predefine the amount of CPU, amount of memory that guest OS would be using. Okay. And if, for example, that application is not using all the resources, that resource would be a wastage there. Okay. So there is no scalability of resource there. So as I said, this particular problem is solved by Docker. Now Docker follows the concept of develop, ship, and run anywhere. Okay, you develop your application on your machine, you package it, you ship it to some other machine, and then start running it on that machine. Okay. Now containers can be considered as process. They are not an OS like we saw here. We won't be installing OS. We would be running processes. Okay, and there is no wastage of resources there. You can run multiple containers on a Docker engine, and the containers can be interdependent of each other. So container can communicate with each other as well. So as I said, they are feasible, faster, and much smaller than what we try to do in virtual machines. So to sum up the things, sum up the explanation, you can consider as container are processes running on top of OS, host OS, and VM machines, that the hypervisor are servers using the host hardware and resources. Okay. So let's see the architecture of Docker. We have your machine, you have a hardware, you have a host OS, then you have a Docker container engine. Okay. And on top of that, these resources are just being utilized by the application. We don't have guest OS. And say, for example, application one is not using all the resources, and application three requires more computing power and memory, then they can share the resources accordingly. There is no hard limit that application one would be using this much amount of resources and so on. Okay, so this is the main concept of Docker. Now let's see what is Docker container. So as per definition on Docker website, a container is a standard unit of software that packages up the code. So all the code that you have, the environment, the libraries, the dependencies, the framework, and then this application runs so that this application runs quickly and reliably from one computing environment to another. So if you have built the package in your machine, you can take this package, install it, ship this package to some production environment where there would be Ubuntu machine, and then directly up that environment, and the application would be running on your production environment. Okay. So the instances that we so to run a Docker container, you need to run an image. So we will be looking what an image is. So as I said, Docker containers are just a process running on your system. They are not an entirely other OS. Okay, they are just process. Like you would have a process like Postman running on your machine. You would have process like Zoom running on your machine. Similarly, Docker is just another process. Okay, you can run multiple containers on the same machine, and the resources on your machine would be shared by that containers. When a container requires high resources, accordingly those resources would be allocated to that container. Now container can start running when you build and run an image. So for that, let's look what images are. So you would be writing a Docker file. In hands-on, you would be looking how to write a Docker file. In Docker file, there are set of steps that we would be mentioning. Those steps would be executed when you run Docker build, and a package would be created. A compiled program, you can consider it as compiled program, would be created. And when you give the run command, this image then can be converted into a container, and you can create multiple containers from a single image. Okay. For example, just to give an example that you can relate, you can you can create multiple objects from a single class. Similarly, you can create multiple instances of an image, which are called containers, from a single image. Now you would be building an image. If you want, you can store this image in Docker Hub. There is a repo where all the images are stored. Or else you can create a zip file of that image, store it in your machine, or else you can just keep it built in your machine. So if you push this image to a Docker Hub, you can, as and when you require, you can pull this image from the Docker Hub and use it whenever it is required for you. Okay, so in Docker Hub, you can have multiple lots of images that are already there in Docker Hub. Okay, so let me show you how Docker Hub looks like. So if you try to pull an image of, say, MongoDB and so on, you can directly access it from Docker Hub. Okay, so let me type something like Python. Okay. So if you see, we have this official image of Python. And if I click on explore, so we have Couchbase, we have Mongo, we have all these are official images, but there are some unofficial images like as well, which are not officially created by that particular company. You have Ubuntu image, you have Node.js image, you have MariaDB image. So these images can be used when you try to mention these images in your Docker file. In if that image is not present in your system, these images are pulled from the Docker hub, and it is being that image is being built in your environment. Okay, so we would be doing that during a hands-on. Okay, so as I said, Docker Hub contains lot of images. Some of them are official images. You can either use Docker file to build an image. So if you have a Docker file, you can use that Docker file to build an image in the production environment, or else you can build an image in your own machine, save that image, and use ship that image to the production environment, and then load that image there and start running container there itself. Okay. So these are the basics of Docker, but again there are multiple things that comes into picture with Docker. It is a vast technology. So there is a company called Docker Incorporated, okay, and there are multiple things like security layers and so on in Docker. So it is in a independently, it's a complete new whole technology. You can have expertise in that as well, but for us like data scientists and machine learning engineers, we just need basic understanding of Docker, how to deploy it. So these are the basic concepts, but you can again deep dive into it and learn more things about Docker there. Okay. So any questions till now on the theoretical concepts? If not, then we can move on to hands-on and then start with our hands-on exercises. Any questions? Okay, so I expect all of them have Postman Docker installed in their machine. Okay, and I hope you guys have Anaconda as well installed in your machine. So anyone with any problems in installing Docker, Postman, or Anaconda? Anyone who does not have these dependencies? Libraries we will be installing. You can install it along with me while I will try to install it on my machine. But I hope all these things are already installed on your machine. The Flask, Docker, and Postman. Any questions, any doubt, any problem in installing any of the dependencies? Okay, so I hope there are no questions. Then we can move on. So, okay, so let's start with the hands-on. When for some part of hardware. So, yeah, so hardware that you, so when you build an OS on the virtual machine, you would predefine that what amount of memory I'm allocating to that OS, okay? What amount of CPU power I'm allocating, what amount of space, hard disk space I'm allocating to that OS, okay? Now, when you allocate all these things and when you start running your OS, the OS would use all these requirement. Okay, so all these memory CPU would be utilized by the OS. It is another thing that whether OS is actually utilizing all of the requirements, but all of them are actually allocated to the OS. So original OS won't be able to use that. So it's just that these OS are built on top of your original OS. So you install a virtual box, you install a virtual VMware or something like that, build an OS on top of that. Okay, so these OS would be using all these requirements from your actual resources like your hardware and so on. So Sandeep, to summarize before we proceed, we would be creating first. We would be going to a Jupyter notebook. We would be creating a breast cancer classification model. We would be doing some data analysis. I won't go much deep into data analysis model building part. I hope those things are clear. So we would be just going through that. We would be building a model. We would be saving that model. Okay. Then using the saved model, we would be building an app, Flask app, to access that particular model to create predictions. We would test that Flask API locally, and if it works, then maybe we can add one more layer on our in our pipeline. That is, we would be adding scaling of our data, and then we would again test the Flask API. If it works, then we would be trying to deploy our model using Docker. Okay, so we would be completely killing the task of our Flask on our local machine. We would be creating a Docker environment, running it, and then we would try to access our API through the Docker container. Okay, so let's start. Okay, so let me see all the directories. Okay, so first I would be listing all my environments that I actually have on my machine. Okay, so I have all these environments. Then I would create a new environment on which I would be, this environment I would be using for working on my Jupyter notebook. Okay, so let's name it something like breast cancer, and I would be using Python 3.7. So I suggest that even you guys use Python 3.7. Okay, I would type yes. This would create my environment. Okay, so the environment is created. When I do conda env list, it would give me the newly created environment. So I have breast cancer environment here. So now I would activate that particular environment by saying conda activate breast cancer. Okay, and if you see here, I have my breast cancer environment activated. So let's install the basic libraries that would be required. We would be using in a Jupyter notebook. First, most important, pandas. So we would be getting NumPy installed along with pandas. So when you try to install pandas, NumPy also gets installed along with it. So pandas and NumPy are being installed. Then we would try to install sklearn. Okay, when we install sklearn, joblib would be also installed along with sklearn, the joblib library that we would be using to save our model. Okay, so next I would be installing pip install s. Okay. Let me see for the zoom option. This is fine, right? Okay. Pip install sklearn. So this would be installing scikit-learn library, SciPy, and if you see, we have joblib also installed here. We would be using this particular library to save our model. Okay. So this is also done. I hope you guys are following me. I hope all these libraries are installed. Next, we would be installing our visualization library for data analysis. So let's install that as well. Pip install Seaborn. So I would be installing two libraries at the same time, Seaborn and matplotlib. So pip install cbon space matplotlib. Okay, cbon matplotlib. All these libraries are installed. Clear it. So let's see all the libraries that I've installed in my machine. For that, I would use conda space list. Okay, so I have pandas, I have matplotlib, I have numpy, I have joblib, I have scikit-learn, I have cbon, I have sklearn. Okay, so these I think these libraries would be enough for me to work on my Jupyter notebook. So Vishal, yes, so this would be pre-installed with Jupyter, but again, one thing is that when you create a new environment, you need to specifically install because the new environment comes as a new package itself. There is nothing pre-installed there. You need to, so when you create a new environment, only Python and basic certificate, all those libraries are installed. Pandas, NumPy, you need to install separately. So when you, so as you saw, I created new environment, and so that is the reason why I had to install all these dependencies. So if it was already installed, it would give me requirement already satisfied, but it didn't give me that pop-up, and it just tried to install everything from cache. Okay. Now let's start our Jupyter notebook. So I think this would not start because I don't have Jupyter notebook installed for this machine. So let's try Jupyter space notebook. Yeah. So it gave me an error. Specified module not found. So I need to install Jupyter notebook. So I would say pip install Jupyter space notebook. So it would be installing Jupyter as well as all the dependencies that are required for running Jupyter notebook. Okay, so I have them installed here. At any point in time, if you don't understand anything, please do let me know. Accordingly, I will explain it. So I have the Jupyter notebook installed. Now I can start it. Okay, Jupyter space notebook. Okay, so my screen is visible, right? I have zoomed it a bit. Okay, so let's start by building our let's start working on this particular application, particular model building. So let me restart the kernel by clearing all outputs. Okay, so first I would be importing all my dependencies. I need pandas to load the data, numpy if required. So just for the safer side, I'm already importing it. Cbon, I would be using it for my plotting purpose. Matplotlib just as a dependency. Maybe I would use the figure size, those things. Joblib I'm installing so that I can save my whatever model I'm creating, I would be saving it using Joblib. Okay. So my dependencies, I have already imported them. Next, I'm creating a variable df which would contain my data frame. So I'm passing a URL to pd.readcsv. This is the URL that I have shared with you guys. Please try to load this and let me know if you are able to do that. It would take some time because it is low. It is trying to read a URL rather than a local file. So once it is done, try to do df.head and check if you are able to access, if you are able to load the data frame on your Jupyter notebook. Please confirm it in the chat box. Okay, so I hope everyone is able to access it. So let's go through the data quickly. We won't do much of a data analysis. So that is the reason why I took a simple data set. So we have all these 31 columns, out of which the last column, the target column, is the column that we would try to predict. Okay. So let's see the distribution of our target column. How many zeros we have, how many ones we have. So for that, I would plot sns.count plot df target. Okay. Once I execute, so it is not highly imbalanced data, but it is a bit imbalanced. But again, we are good to use it. Okay, and if you see, we have the data type as a float on a target column, but I don't think target column needs to be float. So what we will be doing is, let's convert it into integer. Okay, so I'll say df target equal to df target dot as type integer. Okay, so I've converted it into integer. Now if you see right now, previously we had 0.0 and 1.0. Now we would have 0 and 1. Okay, so this is already converted, and if I try to again access the top 5 rows, I can see the change here as well. Previously it was 0.0, 0.0 and 1.0. Right now it's just 0 or 1. Okay, next we would create a pair plot to understand what is the distribution of data frame along with the, so let me paste this in the chat channel, so you can directly copy and paste this code. So I'm creating a pair plot using the data frame. So as you, I'm using the target and variables that I'm creating a pair plot for are mean radius, mean texture, mean area, mean parameter, and mean smoothness. Okay, so once I execute it, I will get a pair plot. So I would understand what is the distribution of how they are related to each other. So mean radius and mean texture, how they are related. So we have a scatter plot here. Okay, so we won't be doing much of a data analysis and data pre-processing here, but just to make you understand of the basic flow that you always go through while building a model. That is the reason I'm trying to do this. Okay. Next, we would see the correlation between the uh, all the numerical columns. So we have just numerical columns. So let's see the correlation between them. Okay. So if you see, we have annotated all the correlations. So I think this is radius error and perimeter error are highly correlated. Okay. And along with target column, all if you see all the black part, they are also correlated, slightly correlated. Okay, so here you can check the correlation among the numerical columns. Okay, so let's consider we have completed the data analysis part. Next, we would try to load the target variable into a y named variable. So target column would be loaded into y variable. So for that, I would say y equal to df of target. Okay. Now the target column is loaded into y. Next, I am storing all the columns and all the rows in x variable except the target. Okay. So if you see, if I just execute this command, I will get all the 569 rows and 30 columns. But if you know, we have 31 columns, but here we got just 30 columns because we have already dropped target here. Okay, so we would be saving this into a data frame with name X. Okay, now let's see what we have in X. So in X we have 569 rows and 30 columns. So we don't have the target column here. In Y we have a series of target column. Okay. Next, we would split the data into training and testing phase, testing size. So we say X train, X test, Y train, Y test. We would be using train test split function. Okay. So as you know, this function takes a parameter of X variable, the X data frame, the target column, the test size. So here we have mentioned that we want test size of 20%. Okay, so the training size would be of 80%, and I'm specifying a random state of 5 here so that I can replicate my results whenever I run this. Okay, If I try with X10, previously I had 569 rows. I have 455 rows. The remaining rows are there in X test. Okay, so let's try to see what we have in X test. I have 114 rows. Okay, let's see what we have in Y-train. In Y-train, we have 455 rows, similar to X-train. And in Y-test, we would have 114 rows. Okay, so I hope till here everything is clear. This is the normal flow we always go through. Okay, so let's not do any pre-processing for now. First, let's build a model directly using this data set without doing any scaling and so. Okay, after we build this data set, we build this model, we would be saving this model. Okay, we would be trying to accessing this model using Flask API. If everything works, then we will add this particular part of scaling the data into our pipeline. Okay, for now we would not include that. So I would be using SVC, SVM for my data for the model building purpose. Okay, so I'm importing XVC. I import all the classification, confusion matrix, and accuracy score from sklearn metrics. I initialize the SVC model class. I create a model object of the SVM. Then I fit the model on X train and Y train. Okay. Once I fit the model on X train and Y train, I can try to predict it whether this is working also. So on Y train, on YPred I have the predictions. So let's see what we have in YPred. We have all these predictions. Let's try to create a confusion matrix of it. Okay, so we have a confusion matrix stored in CM variable. Okay, we have passed Y test and YPred to it. Now we will try to create a heat map to understand what we have in confusion matrix. Okay, so we have 41 uh, 41 plus 66 would be the accuracy. Okay, so we have true positive of 66 variables are correctly detected. Positive. So we have 66 positive variables that were correctly detected as positive. We have 41 negative variables that are correctly detected as negative. We have 7 variables that were wrongly detected as uh, false false positive. Okay, it should be negative, but it was detected as positive, and we don't have any false negative variable. Okay, so let's try to have the classification report. So we have all the precision recall and F1 score here. So by seeing this, we can understand that this is a good to go model. We would try to print the accuracy score. We have 93% accuracy. Okay, till here everything is fine. We have built a model. Now, if so say for example, I have yeah. So if you just try to print CM here, it would give some this kind of result. So instead of this, you can try heat map and not true to understand all the metrics here. Okay. So say for example, I have built, say in actual scenario, you try to build multiple models, random forest, logistic regression, SVM. So you can try this after this workshop. You can try to create multiple models. And say for example, just consider this that I have built multiple models. Okay. But I'm happy with the accuracy of SVM. Okay. So I have 93% accuracy. Then what I would do is I would have a model file name with model.pkl. Okay, this is my model file name. And then I would be using the joblib library that I had mentioned earlier. We would be using joblib.dump to save our SVC model. So if you remember in SVC model, we have our model created. Okay, we have fit our X10 and Y10 in the to the SVC model. So this is our particular model. So we would be saving this model with the file name model.pkl. So for that I say joblib.dump my model and the file name that I want my model to be saved with. Okay, so if you see here, I don't have any pkl file created. But once I execute it, okay, I would have a model.pkl file created. It is of just 33 KB. Okay. So everyone done till here, are you able to save the model? Any issues in saving the model or problem? Any doubt? Great. So you guys would have some model.pkl file. Okay. You can name it anything. I can name it something like SVC model or something, anything. I can name it anything. But for the sake of simplicity, I've kept it model.pkl. Now, let's try to create a new Jupyter notebook. Let's try to access this model without actually training the model. So what we would see is we would see if we are able to access the model. So what we would do, we would just import joblib. We don't need to import sklearn or so. We would be importing pandas because we would be using one of the rows from our own dataset to check if the model we are trying to actually, if the model is working that we are trying to load. Okay. So I import joblib. Then I try to load the model. How do I load the model? By saying joblib dot load and the model file name. So I have model.pkl. This would load my model into this variable. Okay, so my model is loaded. Okay, so I will import pandas. Then I would try to read my whole data frame. I would check the shape. Okay, I would always again convert the uh, last column to integer. So you can ignore these steps. Okay, uh, I can check the data frame head. So I have all these columns. In tail, I can have all these columns. So say for example, I want to predict what is the prediction for the last row. Okay, so what I would do is first I would drop the last column. I would create a new data frame data. In that I would drop the last column. Okay, after that what I'm doing here is I'm trying to get only the last row and all columns. Okay, I'm just trying to get the last row and all columns from my data frame. Okay, from this particular data frame. So once I execute it and once I try to print data, I would have only one row, but without the target column. Okay, why? Because we have already dropped the target column and then we are just selecting the last row instead of the whole data set. Okay, so say for example, this is how the user is passing the data to you. Okay, now since you have loaded the model, you can again try to predict the model by using pred equal to model.predict and then pass the data that you have created to that particular predict function. So once this is executed, okay, I can check what I have in pred. So I have an array of one object. So to access that first object, so I got 1 year. So I'm saying pred of 0 to access the first object. I'm getting 1 as the prediction. So let's see what we had in the last row as actual target variable. So we had 1 there and a model correctly predicted 1. Okay. So that's what I did here. The actual data frame I have, the last column it was actually 1 and the model also predicted 1. So here we can understand that our model is correctly saved and we are able to correctly load the model as well. Okay. Clear everyone till here? Any doubt on how to save or load the model? Any doubt? Okay. Now let's do one thing. First, let's create a Flask API. Okay. So then we would, if time permits, then we would try to include the other thing in pipeline as well. Okay. So what I want you to do is I want you to save both these notebooks into a folder called notebook, or you can name that notebook anything, that folder anything. Okay, and you should have a pkl model.pkl file here. Okay. Next, after that particular part is done, I want you guys to create a new um folder with which is named as deploy or anything like that. You can name that folder anything. So we would be creating all the files required for deploying the model inside this particular folder. Okay, we won't be using Jupyter Notebook anymore. Okay. So let me know once you guys have done this part. I just need you to store all the notebook in one section. Okay, you have model.pkl here in that particular folder. Then create another folder with deploy with the name deploy, and inside this deploy folder we would be creating the actual file that would run the Flask server, and then later on we would be adding the Docker file as well. Okay, let me know once that is done. Decoder. I don't know why do you need decoder. Are you talking about Docker? Okay, okay. So we shall do one thing. Instead of restarting and joining back, you do one thing. You can follow through this. You understand what I'm doing. Okay, and just create these files. Later on, I would be posting my all the commands to actually deploy the code in the chat channel, and you can later on use these commands to try that part. So right now, don't worry about Docker. Later on, you can try this. Okay. So I hope everyone is done till here. Okay. Now in deploy folder, open this folder in a some code editor. Maybe you would be using PyCharm or Notepad++ also works, Sublime works, Visual Studio Code works. Just try to open it. We would be creating few files here. Let me know once it's done. Once you open that particular folder in a code editor, then we can start with writing the code for creating a Flask API. No, no, not that one, Rekha. The one that you recently created, deploy folder. Open that folder in a code editor, the deploy folder, because we would be adding few files in the deploy folder right now. Then we would be moving the model.pkl file, but what first we would be writing some code that we would be saving into the deploy folder. So open that deploy folder. Right now you won't have any files in that. We would be creating that. So open that folder in a code editor. Is it done, everyone? So, okay. So what you need to do is you have a deploy folder. You won't have any files in here. Okay. It would be an empty folder. So if you have Visual Studio Code installed, you can just right click and click on open with code. Or else what you can do is you can open the Visual Studio Code from command line. Okay. And once it is open, say for example, I click on the file part, open folder, and inside open folder, specify the folder that you want to open in case of this deploy, and then select folder. So you would have all these things here. Done, everyone? Done. Great. So now in Visual Studio Code, if you are on Visual Studio Code, you would have a button here. Click on that button, that would create a new file. Okay. Or else you can double click here as well. This would also create a new file. Either of the way, just create a new file, and I will say what I will go through this code. And as I go through this code, just type all these commands in your new file. Okay. So first we would be importing pandas. Why we would be import pandas is because the data that we get from the user would be in a JSON format. Okay, they won't pass it through a CSV and so on. So if the user is trying to pass the data, they would be passing it in a JSON format. If the user is trying to pass it from a UI, the UI would convert it into a JSON format. So say for example, there are multiple text boxes. User enters the values in that text boxes and enter submit. All the values would be converted into a JSON format, and then that JSON data we would be getting in this particular code. We would convert that JSON data into a CSV, into a data frame, into a complete data frame. Okay, so first import pandas as PD. Then we require all these things from Flask. So just say from Flask. Even if you don't have Flask installed, don't worry. Even I don't have that installed. Okay. But just for the sake of writing code, just start writing the code. So start with from Flask import F capital Flask. Here F should be capital. Then JSONify and request. Okay. Then import joblib because we would be loading our model with the help of joblib. Done. So let me zoom in a bit. Is it visible, everyone? So Vishal, don't worry about JSONify. I will make you understand what JSONify actually is. Yeah, Rick, I will explain it one by one as on when we go through the code. Okay. So next, we are creating an object with name app. Okay. So what this particular line of code is saying that I want my code, I mean, all the instances pointed to this file. Okay. So name points to this particular file app.py. Okay. So this is my code. So in Flask, you have templates as well. Okay. So what in templates, you save the HTML code. And then when you say Flask name, it tries to search to this folder itself where this particular file is residing. It searched for the templates in this folder itself if you are using template. But in our case, we are not using template. We would just use the route and all those methods. Okay. So just initialize the app using app equal to Flask underscore underscore name underscore underscore. Done. Next, so we would be exposing a URL. Okay, so something like localhost 3000, localhost 5000, something like that. So on that URL, when the user goes through the slash predict method, okay, what should happen when the user hits this particular URL? So something like localhost 3000 slash predict. So we are routing this, but whenever a user hits this particular URL along with localhost, this particular code should get executed. Okay. And if you user just types localhost 3000, then this particular code should be executed. Okay. So we are just creating a function def function predict, and here we are using post method. So what is post method and get method? Different topic, but just to give you an overview. So in get method, you get something from a server, And in post method is usually used to create or update anything on the database or server. Get method, everything, all the data you pass it in the URL itself. Okay, so sometimes when you log into Facebook or something like that, you would see the data in the URL like slash your name username equal to slash something like that. But in post, the data is not passed through the URL, it is passed in the body of the request. Okay, so when we use postman you will understand it. Post is quite secure because user can't see the data and all, but in case of get, user can actually see the data in the URL. So that is why when we use username, password, and all those things, we use post method instead of get method. Because in get method, user can see username, password in the in the URL, which is not safe. Okay, so post is quite secure in that manner. Okay. Now, before I start, let me show how will our request look like. Okay, so I'm just trying to start the postman. You guys don't need to start it right now. You can do it later on. I'll let you know. Okay, so when I try to access predict method, I would be getting data in this format. So let me grab this. So when I click send this data, I would be getting in my this particular server when I up it. Okay, so this is the data that I'm trying to fetch. Okay, so when I say req equal to request dot get JSON, I would be getting this entire JSON there. So this is the reason why we are using request. Request is the data that user is trying to send to the server for some processing. Okay, so we are using this request dot get JSON. What this will do is all the data that user has passed, we would be using it here. We would be getting it in this particular uh, variable. So in this particular variable, I will have all this particular data, this whole dictionary you can see. Okay. Now what I'm trying to do is I'm taking the input data and I'm just trying to fetch req of data. So if you are aware of dictionary, what I'm trying to do is I got this in request, and when I say req of data, I will be getting just this particular part. Okay, this particular part in my input data. Okay, then I'm creating an input data underscore df, where I'm converting this particular data, which is in a kind of list of dictionary. This is a list of dictionary format. I'm trying to convert it into a data frame. So I'm saying pd.data frame from dictionary. So this is the dictionary that I'm passing, convert it into a data frame. So here I would get a particular data frame. So all these things would be converted into a single row, like we did it in our test part, something like this. It would be converted into something similar to this kind of format. Clear why we use request and what we are doing till here? Everyone clear till here? Everyone clear? Rekha, are you clear why we used request here? So request is just get the data that user has passed in the request body. Okay. So if you see the postman, here we have the body and here we have the request. Okay. So Rekha, we have two methods while you are trying to call an API. You have get method and post method. Okay. So in case of post method, you are trying to pass all the data in the body of that method. So this is the body. If you see, this is the body of that method. Okay, and here I mentioned the request type as post. But in case of get, I would pass the data something like question mark mean radius equal to 10.16, then slash question mark, something like that. So all the data I would be passing in the URL. But so the difference between post and get is the main difference that I can tell you is that in get, you can see all the data in the URL itself. So if we try to build this application, if we try to integrate with a UI part of the application, and if a user try to access URL. Okay, so let me show you one example. Here I have a Docker. Okay, I have a Docker URL. So give me a moment. So this is the UI, but when user, so I press this part. Okay, or let me show. Okay, when I click this part, I can see the URL, but here I can see all the data as well. So this is a GET request. I can see all the data. So this is not secure when we use. Uh, Sorry, I think I stopped sharing this. So this particular URL is not secure when you try passing the username password, because username password would be visible in the URL. But in case of post, the user can't see what actual data is being passed in the backend. Okay, so this is secure. And second thing is, get method is used to get something from the server. Okay, so if we have something that we are trying to just access from the server, we would be using get method. But now if you see, we are not just trying to access, we are using the data from the post request, we are modifying the data, getting some output, and then returning that output. Okay, so post data just post the data to the server, makes some pre-processing and gets back the data, pre-processed data. But in case of get, it's something similar like select statement in SQL. You are just trying to get some data from the server. Okay, you can always read more about that. So let me find a link or so if I have. Mm, okay, yeah. So this is the W3 school links. You can all see all the HTTP methods, and you can go through this link. In this link below, they have mentioned the difference between get and post as well. You can go through it later on. Okay. So any doubt till this part of code? Yes, Vishal, you can go through Geeks for Geeks as well. Any website. Okay. Next, we would be loading our model. So what I'm saying is model equal to joblib. We have already imported joblib. Joblib.load model.pkl. Okay, so I have model in this particular variable. But if you see, we don't have model and model file here. So just go back to your folder structure, take the model file, copy it from here, and save it inside this folder. Okay, then you would see the model pkl. So it can load directly from your the model file. Okay, so we are just loading the model file as before. Okay, just copy the model file into the deploy folder so that we can access it. Okay, next we are trying to get what we are trying to do is we are trying to get the prediction of the data that user has passed. So we have that data in the input data frame, and we are trying to uh, predict the target variable, whether the cancer is malignant or benign. So if it is 0, then we can say that the cancer is benign, which is harmless. And if it is 1, we can say that the cancer is malignant. Okay. So we are trying to pass the data frame here, and we would have prediction in this variable. Next, I don't want to pass the data back to user like 1 or 0. Okay. So what I would try to do is I would say if prediction of 0 is 1, then create a new variable called cancer type with malignant as its with a string malignant in it. Okay, so this is the value that we are trying to store in cancer type. And in the else part, we would, if the data prediction is 0, then we would store cancer type as benign. Okay, so if you remember, uh, here we got the data as pred of 0, we got 1. So that particular cancer type was malignant. Okay, so that's why when I got prediction of 0, I don't want to pass 1 or 0 to back to the user. So I'm mentioning the actual value instead of 1 or 0. So I'm saying if prediction equal to 1, return that data is malignant, else return that the data is benign. Okay, so we have this prediction type stored here. Okay, in the cancer type, we have the type of cancer stored in the cancer type variable. Clear everyone till here? Great. Next, JSONify. Now what I'm trying to do is I'm trying to create a kind of dictionary. So if you see, this is a dictionary, and when you process all the data that the user has sent in the request, while responding you need to respond it in a JSON format. Okay, so I'm creating a dictionary here. Okay, so what the dictionary has is I have an output key output, and the value of key output is another dictionary which has again a key cancer type, and then inside after the value of cancer type key is the actual type, whether it is malignant or benign. And then I'm converting this dictionary into JSON by using the JSONify method. Okay, so JSONify method just converts the dictionary into a JSON format that we would be seeing in the response part of our Postman. Okay, next I'm just trying to create another URL just for the sake of understanding how this route works. So whenever user enters localhost 3000, he would get this on his screen. Welcome to Breast Cancer Diagnostic Center. Okay, so you can consider yourself as a person who is working in the Breast Cancer Diagnostic Center. You are a data scientist who works here, and there people would be sending you the data, and you would say whether the cancer is harmful or harmless. That is whether the cancer is malignant or benign. Okay, and in this part, what I'm saying is run this app on 0.0.0, that is my local host, and on port 3000. So this particular server should be up on port 3000. Okay. Everyone, code is clear to everyone, all of you? Any doubt in code? This is just a single line of code. Okay, a single file of code. What you can do is you can maybe keep all this part in some other file named model predict model.py, and then import that file here and then call that particular function here. But for the sake of simplicity, I kept it in a single file itself. Any doubt on what we have done in the app.py file? Great. Now let's not go into Docker file. First, we will try to run this file locally. Okay. So what I need you to do is, so again, we have this notebook part done for now. We can close it. Okay. Now I would go to cd space deploy dir. I have my app.py here. Okay. So save your file as app.py inside the deploy folder. Okay. And make sure that you have model.pkl file here in that folder. Is everyone with me till here? Everyone save the model.pkl file, app.py file in the deploy folder, and open the deploy folder in your command line. Once done till here, please let me know, then we can proceed. Done, everyone? Okay, so now I have this particular folder open in my CMD. I would just type Python space app.py. So what I'm saying is just run this particular file. So when I press enter, this, okay, so I don't have a Flask module installed here. So now let's do one thing. We would not be using the breast cancer environment for this deployment part, okay? Because we have multiple unnecessary libraries that we have installed, like Jupyter Notebook. We have other libraries installed that we don't actually require for deployment, okay? So what I would do is I would create a new environment. So I would create an environment named conda create -n deploy and same Python equal to 3.7. Okay. When I press enter, a new environment. So these are the initial packages that get installed. Okay. So I would say y This will install all the basic packages when I create an environment. Okay, so my environment is created. Now I would activate that particular environment. Conda activate deploy. Okay. Everyone till here, have you created an environment? Have you activated that environment? Create an environment named deploy. We won't be using breast cancer environment because there are unnecessary libraries. Okay. So what we would be doing is we would be just installing required libraries for deployment inside this deploy environment, and then we would be creating a requirements.txt file, which we would be using in Docker as well. Okay. So let's consider everyone is done till here. That if anyone is stuck, please let me know. Okay. We have a deploy environment. Now I would install all the required libraries like pip install numpy. Okay, instead of numpy, directly pandas and sklearn. And okay, numpy, pip install pandas, sklearn, and Flask. So I'm mentioning all three of them in a single line. Okay, so I have numpy, pandas, joblib, scipy, scikit-learn, and Flask installed. Okay, so it's installing all these libraries. Those who didn't install Flask, you can follow me. You can try all these things along with me. Okay. So if I do conda dot space list, I would get all this environment, all these installed packages. Okay. So let's just go through. Are there any other packages? So we use pandas, Flask, joblib is installed. And since we are loading our model, we have sklearn also installed. Okay. Now let's say Python app.py. Once I enter it, my server is up and running. Okay. So what I will do is I will try to access that URL localhost 3000. Okay. Welcome to Breast Cancer Diagnostic Center. So this is the one. So when I said localhost 3000, this particular route got executed. Okay. Now everyone open your Postman, start your Postman. Okay. One by one we will go. Once you start your Postman, click on the plus button, you will get a tab here. On the request type, click here, click on post. Okay. Here you can type localhost 3000 / predict. Okay. Because our server is running on 3000 and we want to predict the data. Okay. Now click on body, click on raw, click on text and select JSON here. Okay. And now inside JSON, I have a predefined data. So this is the last row or something like that. I can give you this as well. You can paste it in your Postman as well. Okay. Once this is done, I will click on beautify. So it is already beautified. The indentation as all are done. Okay. Everyone till here. Everyone has done this part till here. Let me paste the data once again. I'm not sure if all the data is being accessible to you guys. So let us do one thing. I can share this file. Compactness. Okay, I think half data is only being added to the chat. Let me do one thing. Let me store this file in Google Drive and then I will share the link to you guys. User option. It's not working. Okay, let's do one thing. What I'll do is, I'll add this file to my GitHub. You can access it from there. Okay. Let me go back. GitHub classification. Okay, I have request here. Okay, I pushed it. Let me show you how to access it. I have my GitHub. Go to this particular URL. Okay. Let me share it in chat channel. Go to this particular URL. And once you go there, click on repositories. Go to breast cancer classification. Okay. And here you would see a request.txt file. Just click on that file. You would see the data here itself. So you can take one dictionary. Here we have two dictionaries, okay, two JSON data. Take one of them, copy it, go in the Postman and just paste it in the body. Let me know if everyone is able to do it. Access the GitHub URL, click on breast cancer classification. Inside that you will see a request.txt file. Click on that. Take either of the one dictionary. There are two dictionaries in that. Take either of the one dictionary and paste it in the body part of the Postman. Okay. Everyone done till here? Are you able to do it? I'll wait for a sec or a minute or so. If anyone is able to do it, please let me know in the chat channel so that we can proceed further. If any problem in accessing the URL or so, please let me know. If you're not able to find the request.txt, please let me know. Done, everyone? Okay. So once you paste it, paste the URL, the data in your Postman. Okay. Make sure you have mentioned the URL perfectly, localhost 3000/predict. Or in body, click raw, select JSON, paste the data. Okay. You have post method selected here. Now you have your application running. Okay. Your server is up and running. Just click on send. When you click on send, you will get an output. Okay. So we have output, and inside output, we have cancer type equal to malignant. Okay. So what this means is the data that user has passed, that data says that that particular cancer patient has malignant cancer. Okay, so here we are able to do it. We have wrapped everything in a Flask API. We are able to access it. Okay, now you can give this URL and uh, sample data to the UI guys who can then integrate it with their UI. Okay, everyone done till here? Any doubt in any part of this? Okay, so if you have any doubt, please do let me know. Okay, now I will turn off my server. We will shut down the server. Okay, and if you try to again click on that link, it won't work. It will give you an error. Okay, connection refused. Now let's quickly do one thing. Let's quickly what we will do now is we will add a pre-processing method as well. Okay, so for that, keep these files as it is in your deploy part. Okay, okay, so this URL won't work now because we have stopped the uh, server. Okay, now go back to your command line. Okay, open the folder where you have your notebooks. Okay, now start the activate your breast cancer environment. Conda activate breast cancer, and then type Jupyter notebook. Now what we did till now is we just tried to pass the plain data to the model. Okay, now next what we are trying to do here is now we would do the same all these things as it is like we did before, but now we would add a pre-processing step where we would scale the data as well. So if you see the data here, we don't have the data in a scale format. Okay, so the unit for all these columns are different. So we would scale the data. Okay, so what I'm doing is I'm saying scale on input pre-processing. I'm adding the I'm fitting the data to the train x.train method. Okay, okay. So just use fit. Don't use fit transform. Just use fit. The reason why, what is the reason I'll tell you later on. But for now, just use fit and store it in a scalar of obj. Now I'm using scalar obj to transform x train. Okay, so my new data would look like x train scaled. How it would look like. So I have everything scaled into a in between 0 and 1. My x test is not yet scaled. So we will scale x test as well using scalar obj dot transform x test. Then we will look onto x test scaled. So I have test data scaled as well. Okay. So guys, you do this till here. Scale the train data and x data. First, fit it to the train data. Store it in a scalar obj. Use that scalar obj to transform the x data and x train and x test. Okay. use the previous notebook itself. Just add these steps. What you need to do is sklearn, from sklearn import preprocessing, scalar equal to preprocessing dot min max scalar, then scalar obj equal to scalar dot fit on extend, just fit, not fit transform. Okay, and we are storing it in scalar obj. Then we are creating xtrain scaled using transform on xtrain. We are creating xtest scaled using transform on xtest. Once this is done, save a create a file called scale.pkl, similar to what we did in model.pkl. Okay, so what we are doing is we are storing this scalar object into a file called scale.pkl. Okay, so same code, scalar file name equal to scale.pkl, joblib.dump the scalar object, the actual scalar object, and the scalar file name. So if you see now, I have those things stored in my notebook. So I have scale.pkl, which just got stored in by 3:38 p.m. Okay, so let's go back. Done till here. Now what we would do is we would again train our model, the SPM model, but now we would train it on the, instead of X train, we would train it on X train scaled. Okay, and Y train would be the same. And then we would predict on X test scaled. Okay, we would test it on X test scaled. Then we would have YPred, we would plot the confusion matrix. But if you see, we have only two incorrect variables, so incorrect predictions. So we have our accuracy improved by adding the scalar method. We can print the classification report, and my accuracy, previously it was 93, but now I got 98% accuracy. Okay. So this is my new model. Hence, I will store my model. I will restore my model with model.pkl. Previously, my model was saved by 252. Okay. Previously, it was saved by 252. Now, if I save my new model, this file will be replaced with the new model. So if you see the date modified, it is 339. Done till here, everyone? Are you able to store the scale and model PKL file? Once done, copy both these files, scale.pkl and model.pkl, go into deploy folder, paste it here, replace the existing model.pkl file with new file. Okay, so now what we would be doing is, what we currently did was we also added one thing to the pipeline, is a preprocessing step called scaling, where we are converting all the values in from a number between 0 to 1. Okay, but now in the API we need to do the same thing, because when user pass the data in different format, we need to scale this data as well, because our model expects a scaled data now. Okay, so just add these three lines there. Okay, I will send it to you. So we would be printing the scaled object as well. So what we are doing is we are so Sandeep, which changes you need me to explain it once? On the Jupyter notebook or the, so let me go through the Jupyter notebook once more. So what we are doing here is we are adding the sklearn.preprocessing. We are adding one more thing to our pipeline. Previously we were not doing scaling. So I added a scaling code where I'm storing the scalar object. When I did scalar.fit xtrain, I'm storing it into the scalar obj. Okay. Then I'm scaling my xtrain. Then I'm scaling my xtest using scalar obj.transform. After that, I'm storing the scalar obj into scalar object into a scale.pkl file, similar to what we did in model.pkl file. Okay. And after that, I'm retraining my model with the scale data. Okay. After that, I'm retraining my model with the scale data. So now my new model is trained with a scale data instead of normal data. Okay. I have my accuracy improved. Now I am saving. Now my model is changed because previously it was trained on a raw data, but right now it is trained on a scale data. Okay. So I would again save my new model. Okay. I am using joblib.dump. My model is saved. Okay. Now what I need to do is I just need to take these two files, model.pkl and scale.pkl. This contains the scalar code, this contains the model code. I need to take these two files, copy it from my notebook part and just paste it in my deploy folder. Okay. Now once I am on a deploy folder, I have both these files. Now what I'm doing is I'm loading the scale object. I'm saying joblib.load scale.pkl. This loads the scale object on scale.obj. Then I am converting the input data df. Previously, we were directly computing the prediction using the input data as it is. But now we would convert the input data. We would scale the input data as well. Okay. So we are saying input data scale obj dot transform input data. This would scale the input data and then store it in a variable called input data scaled. Okay. Then I'm printing it. You will understand how the scale data looks. Okay. I'm copying this input data scaled and passing it to the prediction pipeline. Okay, so I'm saying model.predict the scale data now instead of raw data, because now our model, this new model.pkl expects our data to be scaled instead of raw data. Okay, remaining part of the code remains the same. Okay, so let me share these 4 lines of code. Just make sure you have model.pkl and scale.pkl. Model.pkl should be the new one that you saved right now. It shouldn't be the old one, because old model.pkl was expecting raw data, the data as it is. But now this new model.pkl would expect scale data. Okay, so make sure you change both, have both these files updated here. Done till here, everyone? Any doubt? So I would stop my Jupyter notebook. Now we don't need the Jupyter notebook part. So let me close that window. I don't need Jupyter notebook. Let's activate our deploy code once again. Conda activate deploy environment. Conda activate deploy, because we have Flask and all the only the required libraries installed in this particular environment. Okay. Now, since we have saved the code, we have made the changes to the code. Let's run our server by saying python app.py. We didn't add any new libraries, so there is no need to install new libraries. Okay. Once I execute it, okay, I'm in wrong folder. Cd space deploy. Go into deploy folder and say python space app.py. My server is running, right? So let me try to access the server. Localhost 3000. This is working, right? Now use the same data that you had used previously on Postman. Okay. Now, if you see the data here, we have it is 10.16, 19.59, 64, and the unit is different. The numbers are varying highly. Okay. Previously, our model was able to predict this as well, but now we would scale this data and then pass it to the model for prediction. Okay. So when I send it, I'm getting prediction. But if you see in this server, since I added this code, print input scale data, you can see the scale data. So our scale pipeline has run here. Okay, so my data, the data that I'm passing here, all these data, they have been scaled, and then this scale data is passed on to the predict function for predicting the data. And I got malignant again. Okay, so I'm just trying to make you understand how you should add other things in pipeline, like one hot encoding. In one hot encoding, you should encode the data. You should just fit the data. Um, Let me see if I have zoom option here. Okay, so I have all this data here, and I have my prediction here. Here you can see all the data. Since I have zoomed, I'm unable to show the whole data. But again, here I have entered my data. When I do send, I get. So if you see send, when I do send, it shows sending request. This request goes to our server, and then we get an output from our server. We got malignant here. Okay, so it is working fine. So what I'm trying to make you understand is just you can add all the preprocessing steps in a similar manner. Okay, you can do one hot encoding. You can fit the data on one hot encoding, save that file somewhere, one hot encoding.pkl, and then you use it in your Flask API. Everyone done till here? Next, we would go through the model deployment using Docker. Okay, so let me close this, stop the server, and if I try to run the server, it would give me an error. Connection reboot could not send. Okay, so let's stop this. Okay. Now what we would be doing is we would be running this server on a Docker container. Okay. Now for a Docker container, we won't be creating an environment in a Docker container. Okay. So Docker container, you can consider it as a machine where we would be packaging all the required code and then running the code in that particular container. But for that, what you need to do is you need to save a requirement.txt file. So we have all these dependencies to run our server. So we have all these dependencies. We have joblib, we have pandas, we have numpy, we have scikit-learn, and we have sklearn, we have uh, Flask as well. Okay, so what I would do is I would save it into a pip.requirement.txt. We would save it in a requirements.txt file. Okay, so how I would do it, I would say pip freeze greater than sign requirements dot txt. Okay, pip freeze greater than sign requirement dot txt. When I enter it, I can see the file here. Okay, so if I click on this file, you can see the file here. Okay, all these dependencies with their version number have been saved in requirements.txt file. Okay, now what we need to do is we just need to run pip install minus r requirements.txt in our Docker container so that all these dependencies are installed there. Okay, so how we would do that? First, save this requirement.txt file. Now create a Docker file. Just name it Docker file. Okay, don't give any extension. Just name it in this manner: dockerfile, Docker file. Create a new file, name it Docker file. Okay, so you need to do something like Docker file 1, something like this. Okay, once it is created, now we would be adding some instructions. Okay, what I'm doing is I'm pulling a Python image here. I'm pulling a Python image from the Docker hub that I had showed you earlier. Okay, we would be using this Python to run our server on Docker container. Okay, so I'm just pulling the Python image here, Python 3.7, as we had installed used Python 3.7 there while running our Flask on our machine. Okay, then I'm creating a work dir called /app. Okay, this is my work directory. Next, I am copying all the contents here in this particular folder. I'm copying all the contents in this particular folder to /app folder in my Docker container. Okay, first I'm pulling the Python image, then I'm creating a work directory called app. App is the new work directory in my container. I'm copying all the code, all these files. Sandeep, I will let you know why we are creating requirements.txt file. Okay. So first we are copying all the code here into the /app folder. We are copying all app.py, model.pkl, model.pkl, requirements.txt, scale.pkl into this particular folder, app folder in our container. Okay. Then we are saying that run this particular command, pip install -r requirements.txt. So what will happen is, so Sandeep, here we are using that particular thing, that we are using this particular requirements file, and we are saying that in that Docker environment, in that container that I'm trying to create, install all the dependencies, because these dependencies will be used by my model, okay, by my app.py file. Okay, so I'm saying install all these dependencies in that Docker container. You can consider that I'm creating a machine and saying that inside this machine install all the dependencies that I have mentioned in my requirements.txt. So this particular command will be run. I'm saying run pip install -r requirements.txt. Then I'm giving an entry point Python. So we would be running a Python code and then I'm saying cmd app.py. So what it will do is it would run Python space app.py inside the container. Okay. So let me paste this here in the chat channel. Make sure your code looks similar to this. Again, let me go through this Docker file. This is the file that we use to create an image, and then from that image we create a container. So we will do that as well. First, we would pull Python image from the Docker Hub. Then we are creating a folder called app. We are copying all the contents in our current directory into the app folder. The scale, pkl, requirements, model, pkl, app.py, everything into app folder. Then we are running pip install -r requirements.txt. This will install all the dependencies that we have in requirements file, so that our app.py can run easily in there. Okay. Then I'm saying entry point Python cmd equal to app.py. So this would start my server. Both these things would start my server. Okay. Everyone created the Docker file here. So as you know, Docker file won't have any extension .py or .txt. It would be just Docker file. Okay. I have added the instructions for creating Docker file in the chat. This is the instruction that I have mentioned here. I have added these instructions in the chat channel. You can directly copy and paste it in your Docker file that you have created. So once done, so I think everyone has installed Docker. You can see what is running in Docker. Okay, so you can click this particular arrow. You would see a Docker logo here. Double click on it. Okay, this would start this particular dashboard. It says no containers are running. Okay, then I click on images in the left side. I can see no images here. Okay, now I will show how to check the same thing in our in cmd as well. Okay, so what I'm doing is I'm saying Docker. So let's check the version first. So I have Docker community version 19.03.13. Okay, Docker version will get me the version of Docker, all the information. Okay, then if I do Docker ps -a, I would get all the containers that are running in my Docker engine. So I don't have any containers running in my Docker engine. Next, if I do Docker images, I would get list of all the images that I have built on my Docker engine. So I don't have any images. Similar to what we saw, no containers running, no images. Okay. Now we will try to build an image. Okay. Make sure everyone is inside the deploy folder in CMD. Okay. And your deploy folder contains the Docker file that you just created. Right. Now let's go to command line. Now follow what I'm doing here. Type Docker space build space -t. So what I'm saying, build an image from the Docker file in my in this particular folder. So I have only one Docker file in this particular. Build an image from it. -t says that tag that image. Okay. Now I would give that image a name called breast cancer class. Okay. And after that, I would give colon and I would give 1.0. So this is my image version. What I'm saying is docker build minus t, build a Docker image with the Docker file that we have created, name the image as breast cancer class, and the version would be 1.0. Okay. And after that, give a space and press dot. Put a dot. What this would do is it would search in this particular folder for a Docker file. So in deploy folder, we do have a Docker file, and it will run all the statements in that Docker file to build an image. Okay. Once you type this command, press enter. Before that, let me give this command to you on chat channel. Docker build minus t breast cancer class 1.0 space dot. Okay. And when we press enter, the Docker engine starts building an image. Okay, so this would take some time. What it is trying to doing is it is trying to run each and every command there. Okay, it is trying first it took the file from Docker hub. Okay, then it tried to create a work directory. Then it copied all the contents from current directory to app. Okay, then it's trying to do pip install minus r requirements.txt. It is installing all the dependencies. Okay, so this would take a bit time. So, okay, so if you see we have an image getting built here. I think it is still running, so we should wait. Okay, so we have all the that particular image build. Okay, all the statements are executed. If you see in this particular dashboard, you can see an image here. Okay, we have an image breast cancer class, and you can see that there is no container running. Okay, so we have a command to run the container. So let's copy it. Okay, let's not copy it. I will explain you how to run the image, build image, how to start the container there. Type cls. Okay, clear everything. Now start here. Say docker run. Okay, I am saying to run a particular image. I would say docker run minus p. Give some port number. This is the port number of the Docker container. This is the port number that we have mentioned in our app.py. Okay. Then there is a breast cancer class. This is our image name, but after image name, you need to mention uh, your version as well. So we had 1.0 as the version, and let's see. Okay. So this is the basic command: docker run minus p Docker containers port 5000 and our port that we have mentioned in our server while creating a server 3000. Breast cancer class, the image name that we built, and then the version number. Okay, and if we enter now, it is running, but you won't be able to access it through 3000. Why? Because what we have done is we have mapped 3000 to Docker containers 5000. So since we are running a Docker container, type 5000 here instead of 3000 and try to send it. You would get an output. Okay. Now, if you see, you can see all this data being uh, outputted in your all this data being logged in your command line. To avoid this, stop this. Check for Docker PS if there is a container running. Okay, so we have still a container running even if we have stopped it. You can either stop it by using Control C. Okay, still it works. But now I will show you another way to start a container. So what I will do is I will first remove this particular container. I will say Docker RM -F, forcefully remove this container. E4, I would give few characters of the Docker container ID. I'm saying E468. This would be enough. Okay, so if you see, I don't have any container running now. Okay, if I do Docker PS, I don't have any container. So let's execute the container command. Now, if I don't want all the logging to be done here, I would say Docker run -D, just add a -D before -P. So -D space -P. What it would do is it would run this in a detached mode. Okay, it would not run, it would not log everything in your command line. And if I execute it, it will just give me an ID, and it will, I will have my Docker container running now. Okay, all these things would not be logged, but in this particular part, in this dashboard, you can see the container that we had created. Okay, and you can see the logs here. Okay, if I again execute it, it would give me the log. Here we have 3 predict method called. Okay, now let's try to access the localhost 3000. Localhost 3000. So 3000 doesn't work. We would have to mention Docker's port 5000. So see, your get method was called. Okay, again I called the get method, then one post method. Okay, so you can see the logs. You can delete the container from here as well. Okay, you can. I'm now I'm deleting this container. Okay, images, I can delete this particular image as well. Remove. Okay, now if I do Docker PS, I don't have any container. If I do Docker images, I don't have any image as well. So to sum up everything, now what you can do is you can take all these files, you can take this deploy folder, you can transfer this deploy folder to your production environment or to any other machine. Even if your friend, say for example, you guys have a laptop in your home. Okay, take this Docker file, just install Docker in the other laptop that you have. You don't need Python, any of that stuff in that laptop. Just install Docker, take this folder, pass keep copy this folder from here and paste it in your new other laptop. Okay, and just run all these commands. You would be able to access this particular prediction method in that particular laptop as well, wherein you don't have Anaconda, wherein you don't have sklearn installed, wherein you don't have anything. You can do this same in this production environment as well. Take all this take this particular folder, transfer it to your production environment, and just run the Docker file, the one we did, like Docker build, that would create an image, then Docker run, that would run the container, and then you can access the URL. Okay, so this is the way you deploy. There are multiple other things, like I said, in pipeline. So you can go through this particular URL, sklearn pipeline. Okay, so here what they have done is they have prepared a pipe. So sklearn has a pipeline method, okay, pipeline class. They have prepared a pipeline with standard scalar and a SVC. And when you say pip pipe.fit, this particular pipe.fit, the extend would first go through this particular standard scalar, and then it would go through SVC. You can go through this, but this is bit advanced stuff, but you can go through this URL and look for how the things are done. Okay, now I would suggest you guys to add all this stuff, put it in your GitHub, because deployment is one of the things that company requires. Company wants a data scientist to know. Okay, so this is one of the crucial skills that will help you to get a job easily. Mention it in your resume as well. So here we have completed a workshop. So I would open I would be open for any questions. Any questions, doubt, anything, please do let me know. I will clear it. Okay, so seems we don't have any questions. Thank you everyone for your time, uh, for all the time that you have given. Thank you all. Thank you everyone. Have a good day.
Thank you so much, sir. So now
Thank you,
we can
Purtesh.
wrap up. Yeah.
Yeah, sure.